In this video, I'm going to cover the stack data structure, and we'll use Java to build our own stack. You can think of the stack data structure like a stack of cards. The last card that gets added into the stack is also the first card that gets removed from the stack. This action of adding to and removing a card from the top of the stack is categorized as last in, first out, otherwise known as LIFO. So now let's have a look at building a stack in Java. So the first thing I'm going to do is add a generic type to this stack. This will allow us to specify the type of data our stack will store. Now I'm going to declare a method that takes a generic item and inserts it into our stack. This is a common method to all stacks and is known as push. And I'm going to create a method to remove items from the stack as well. This is called pop. Before we start implementing these methods, I'm going to declare a private class called node. This class will handle our items as well as keep track of the next item in the stack. This class is private because we don't want other parts of our code trying to access our stack. This is why the push and pop methods are public. Right, so now we have our data field, and I'm just going to add a reference to the next node in the stack. And I'm just going to finish this class by adding a constructor which creates a node with our data field. Now back in the stack class, I'm going to add a top field so it's easier to keep track of when we're adding to and removing data from our stack. Right, so now let's implement the push method. The first thing I'm going to do is add a generic item as a parameter. Then I'll use our constructor to create a new node t that takes in our item. Because this item is coming in, our current top becomes second, so we make t.next equal to top. And finally, we make t the new top. For the pop method, we need to return the item in the stack that was removed, so we'll start by declaring this item. Then, to avoid a null pointer error, we'll check if we have an item in our stack by doing if top is not equal to null. In the if condition, we'll assign the data in top to the item we'll return. And then our new top is the next item in the stack. So we'll do this by doing top is equal to top.next. Finally, we'll return item. Now let's test our stack implementation by creating an instance of it in the main class. We'll do stack s equals the new stack of type integer, and then we'll start pushing items in stack s. So we'll do s.push10, s.push20, and s.push30. And now let's see what happens when we print out s. So we get an object reference. To actually see what's in s, we need to override the toString method. We'll start by adding the override annotation and declaring our toString method. Then I'm going to create a new node current to keep a track of each item. And I'll create a list called stack items, which we'll use to hold the data from each node in our stack. Now I'm going to do a while loop to run through our stack by checking if current is not equal to null. In the loop, we'll add the data in the current node to our stack items list. And to continue looping through the stack, we'll set current to the next node in the stack. Finally, we'll return stack items.toString to end the method. Now let's go back to our main class and try to print our stack. Remember, with stacks, the last item that was added in is the first item in the stack. So we're expecting to see 30 as the first item here. And we can see that our stack has all three of our items in the right order. Now let's do s.pop to remove an item, and we'll print s to test our pop method. Here we're expecting 30 to be removed, so 20 will be our new top. And we can see that 30 has been removed, and all that we have left in our stack are 20 and 10. Stacks are really useful in computing, and one of the most common features that makes use of stacks is undo. So if I just hit Command-Z on Mac or Control-Z on Windows, I've effectively popped the most recent thing in my stack to undo what I typed. And there we have it. We've built our own stack. Hope this was helpful, and thank you for watching. See you in the next video.